Hello everyone. In this video, let's discuss how to write a program to design circular queue. Design your implementation of the circular queue. The circular queue is a linear data structure in which the operations are performed on FIFO, first in, first out principle, and the last position is connected back to the first position to make a circle. It is also called as ring buffer. So here we have to implement the circular queue. One of the benefits of the circular queue is that we can make use of the spaces in front of the queue. In a normal queue, once the queue becomes full, we cannot insert the next element even if there is a space in the front of the queue. But using the circular queue, we can use the space to store the new values. So here we'll go for the implementation of the circular queue. Implement myCircularQueue class. So here they have given certain methods. We have to write the code for those methods. First one is myCircularQueue k initializes the object with the size of the queue to be k. So here they have given what will be the size of the queue. That value will be stored in the variable k and we have to initialize that. Next, int front method gets the front element of the queue. If the queue is empty, I have to return -1. The next method is int rear. It returns the last element of the queue. If the queue is empty, it returns -1. Next one is boolean enQueue. So enQueue is nothing but inserting the element inside my queue. So it inserts the element in the circular queue, returns true if the queue is successful. Boolean deQueue. deQueue states the deletion. So it deletes an element from the circular queue. It returns true if the operation is successful. Boolean isEmpty, checking whether the queue is empty or not empty. Checks whether the circular queue is empty or not. Next is isFull, checking whether the queue is full or not. You must solve the problem without using the built-in queue data structure in your programming language. So here I have to implement circular queue, but I should not use inbuilt method or inbuilt queue. Okay. So here they have given the example. So they have given the method names, myCircularQueue, enQueue, and the value also they have given. So myCircularQueue, size of the queue is 3. enQueue, I need to insert element 1. enQueue, insert element 2. enQueue, insert element 3. enQueue, insert element 4. Then rear, I need to print rear element, checking whether the queue is full. Delete the element. Again inserting. Then finding rear. Okay. This is the output, whether the operation has been successfully done or not. Okay. Now let's go for the program directly. So first one, myCircularQueue. So what is the purpose of myCircularQueue? It is a constructor. I need to initialize the object with the size of the queue. So for that I have to take an array. I'll declare that array outside the constructor. So here I am going to give it as final because the array value will not be changed. It's fixed. So I'll give int a. Okay. Now I have to initialize the value here. So what I'm going to do, a is equal to, I'm going to initialize the object. So a equal to new. It allocates memory. New keyword helps us to allocate the memory. Int of what will be the size of the array. So that is given by the variable k. So I have given this. Fine. Now I'll declare few more variables. So what is the purpose of those variables are? If I'm inserting an element inside the queue, I'll be using the variable called rear. If I'm deleting an element from the queue, I'll use the variable called front. So I'll initialize those variables. Int front equal to 0, rear equal to -1. Length, to know the length of the queue, I'll take a variable called length. I'll initialize the value as 0. Done. Now I'll go to next one, enQueue. When I say enQueue, what I'm going to do? I'm going to insert the element called 1 in my queue. So here, first thing I have initialized the object with the size of the queue. So after this, what happened? So array has been initialized of size 3. So this is an array A. I'll give index value a of 0, a of 1, a of 2. Fine. Next, enQueue. Now I have to insert an element inside my queue. Okay. Here I have to take 3 variables: front, rear, len. I'll take 3 variables. Front, rear, and len. This is rear and this is len. Value of front is 0, the value of rear is -1, and the length is 0. Done. enQueue, I need to insert element called 1. So I'll go to the enQueue method. So the value 1 is stored in the variable called value. Okay. Before inserting an element inside the queue, first I have to check whether the queue is full or not. If the queue is full, I cannot insert element inside the queue. If the queue is not full, I can insert the element inside my queue. So for that, I'll check the condition if is full. So here I am checking if the queue is not full. So I'll take not operator. If the queue is not full, I can insert the element inside my queue. In case if the queue is full, what I'll do? I'll go to else. So here what they have given, insert element inside the queue, return true if operation is successful. So if it is not successful, I'll return false. So I'll give return false. Here I am calling a method called isFull, checking whether a queue is full or not. So already I have a method called isFull. I'll write the logic here. So how come I know whether the queue is full or not? I have to check whether the length is equal to size of the array. If it is equal, then I can say the queue is full. If it is not equal, the queue is not full. So directly I'll give return length equal to a dot length. Array name is a, right? A dot length. If the condition is true, it means the queue is full. So what is the length value? Length value is 0. What is my array? 3. Length of the array is 3. 0 equal to 3? No, condition is not true. If the condition is not true, it will return false. I'll go inside. I'll insert the element inside my queue. Okay, so if I'm inserting an element, I have to use a variable called rear. So I can insert element at the back side of the queue. I have taken a variable called rear. First thing I have to take rear. So rear value has to be incremented by 1. So rear equal to rear plus 1. So rear value was minus 1 initially. Now I am adding it by 1. It's become 0. On the index value is 0. I'll be adding the element. Okay. Now the queue is a circular queue. So I have to modulus by the size of the array. Because once after completing the last element, it has to go to the front element. That is why I am performing modulus operation here, because this is a circular queue. So rear value was minus 1. Minus 1 plus 1, it is 0. Okay. 0 divided by 3, still the remainder is 0. Now the rear value is 0. On the index value 0, I have to insert the array element. So I'll be giving a of rear is equal to value. Okay. Next, what should I do? I have to increment my len value. Len value will be incremented because I have inserted one element. Now I have one element in my queue. After this, I have to return true because I have successfully inserted the element inside my queue. So what happens here? Here I'll be inserting the value called 1. Length value has been incremented by 1. Next, again enQueue. Now 2 has to be inserted. So check the condition. Queue is full. Length value is equal to 1. And the size of the array is 3. 1 equal to 3. Condition is false. So it written false here. Not a false, true. So condition is true. I'll go inside. I'll be incrementing my rear value. Rear value will be incremented by 1. From 0 it becomes 1. Modulus 3 it is still 1 only. So on the index value 1 I have to insert the element called 2. So 0 plus 1 1. On the index value 1 I have to insert the element called 2. After inserting I have to increment my len value by 1. So len becomes 2, which states that I have 2 elements in my queue. Then I'll return true. I'll go for the next operation, that is enQueue again. I'm going to insert an element called 3. So check whether the queue is full. 2 equal to 3. No, 2 is not equal to 3. So queue is not full. So I'll go inside. Rear equal to rear plus 1. Rear value was 1. 1 plus 1 it is 2. On the index value 2, I'll insert the next element called 3. After this, increment the len value. Now len value becomes 3. Done. And then I'll return true. It comes out of this. Then I'll go to the next one. enQueue again. Okay. Now I am trying to insert an element called 4. Fine. So go to this enQueue method. Value is 4. Check whether the queue is full. I'll go here. Len equal to a dot length. Len is also 3. Length of the array is also 3. 3 equal to 3. Yes, condition is true. So the queue is full. It will return true. So isFull method will return true, saying that the queue is full. So it returns true. Not of true, false. So I'll go to else part. It returns false, saying that the queue is full. I cannot insert element inside my queue. So it returns false. enQueue method will return false. So here I have not inserted the element. That is why I have written false here. See here, I have written false. Then I'll go to the rear method. So what is the purpose of rear? gets the last item from the queue. If the queue is empty, I have to return -1. So I'll go to the rear method. Now I have to check. If the queue is empty, I have to return -1, else I have to return the element. So here I'll give return. First I have to check whether the queue is empty or not. So I'll call a method called isEmpty. I'm calling a method isEmpty. If the queue is empty, I'll return -1. If the queue is not empty, I have to return the last element. So the last element is stored on the index value 2, that is taken by the variable called rear. So I'll give a of rear, last element. So here I have called a method called isEmpty. So how come I can know whether my queue is empty or not? So I have to check if len value is equal to 0, the queue is empty. So I'm calling is method. It goes here checking whether the queue is empty or not. Here queue, if the length value is equal to 0, the queue will be empty. If length is not equal to 0, the queue is not empty. So in this case, len value is 3, queue is not empty. So I'll give a of rear. So rear value is 2, a of 2 value is 3. 3 will be returned. See, I have written 3 here. Then I'm going to the method called isFull. I'm checking whether the queue is full or not. So here I'll go isFull. Len value is equal to 3. Length of the queue is also 3. So condition is true. So it returns true. See here, it returns true. isFull method returns true. Done. Then I'll go for deQueue. Next, I'm going to delete an element. So when I go for deQueue, what I have to do? I have to delete the element and I have to return true if it is successful. Okay. So when we are deleting an element, I have to check one condition. If the queue is not empty, then only I can delete. If the queue is empty, I cannot delete. So I'll give a condition. First I'll check is empty. So if the queue is empty, I cannot delete, right? So I'll give not of queue. If the queue is not empty, I have to delete. If the queue is empty, what should I do? I have to return false. Done. If the queue is not empty, what should I do first? So here deletion is happening in the beginning of the queue. So first I have to delete this element. First one has to be deleted. That is taken by the variable called friend. So what I'll be doing is friend equal to friend plus 1. See, initially friend value was 0. 0 plus 1, 1. Modulus a dot length. Why am I doing modulus operation? Because it is a circular queue. A dot length. So 0 plus 1, 1. So friend value will be moved from 0th index value to this index value. This value will be deleted. After this, what I have to do? I have to decrement my len value because I have deleted one element from the queue. So length value has to be decremented by 1, which means I have 2 elements inside my queue now. After this, what I have to do? I have to return true. Done. So I have deleted the element dequeue. I have deleted the element. So it returns true here. This true. Next, enQueue. I am going to insert the element called 4 now. Okay. Now let's check where I am going to insert the element called 4. Okay. Again, I have to go to the method called enQueue. So first I have to check whether the queue is full or not. So when I call the method is full, length value is equal to 2. A dot length is 3. 2 equal to 3. Condition is false. I'll return false here. Not a false, true. I'll go not a false. It's if condition is true, I'll go here. Rear equal to rear plus 1. What is my rear value? 2. 2 plus 1, 3. 3 modulus 3. 3 modulus 3. Now you can get to know why am I giving modulus of a dot length. Because again I have to go to the first element. The size of the queue is 3. Now I am going to the index value called 3. But array index value starts from 0 to 2. So 3 I have got. Now I have to go to the first element again. First index value again. So when I perform modulus operation with the length of the array. So 3 modulus 3. So rear value is 3. Modulus 3, it is 0. So I'll go to the index value 0. I'll insert the element called 4. So 3 modulus 3 is 0. A of 0, I'll insert the value called 4. Now len value will be incremented. Now len value becomes 3. See, length value becomes 3. Then return true. So here I have written true. I have inserted the element successfully. Next is rear. So what is the purpose of rear? It returns the last element of the queue. So here check whether the queue is empty. Queue is not empty because len value is not equal to 0. Queue is not empty. So I'll go for a of rear. So rear value is 0. A of 0 value is 4. 4 will be returned. See, 4 will be returned here. Here we have not completed the method called friend because they have not called in example 1. So let's write the logic for friend also. So what is the purpose of friend? it returns the front item of the queue. It returns the front element of the queue. How come I can know the front element? If I take the index value of front, I can return the front element. So for that I have to check whether the queue is empty or not. Return is empty. If the queue is empty, I return -1. If queue is not empty, so front is pointed by the variable called front. That's all. Let me run the code now. Okay, there is an error. I have missed a semicolon here. See, it states it's expected semicolon. Line number 12. Okay, I have missed a semicolon here, and line number 28 also I have missed a semicolon here. Fine. Let me run the code once again. Yes, it passes test cases. Let's submit the code. Yes, it passes all the test cases. That's all.